be factored in. So that being said, let's move on to question number 18. What is the electron geometry of ClO3 minus? So this will be like a chlorine trioxide ion. And that's the best thing I can think of. Or actually, what am I doing? This is ClO3. This would be a chlorate ion. Yes. In fact, let's double check. Let's use the same trick. Chlorine. Let's go to the periodic table. Let's, well, use the, as we're using electron geometry, I know I didn't do it for the last question, but it's always good to just practice. We have helium for chlorine, well, helium for oxygen at least. 2s2, 2p4. That's going to be 6 electrons. And now chlorine, we have, starting at neon, okay, we have 3s2, 3p5, okay, I mean it has 7 of those electrons, which makes sense. And now let's see if we actually have the name chlorate, a chlorate ion. That's what I'm thinking it is. Okay, and with that being said, let's see for the orbital, oxidation number. Okay, chlorine, as you said, oxygen. In this case, this is a rare case where chlorine would actually be a bigger bully than oxygen. That makes sense, because these ones you kind of have to, I guess, work your way around. But in a sense, let's just say it's 2. Okay, we don't give it a charge yet. 6. Chlorine, we know it can give away 7. Okay, I mean not give away. We know that it has an oxidation number of 7. Whether it's plus or minus 7 depends. So we have 7 and 6. To get -1, the 7 needs to be negative and the 6 needs to be positive. Okay. And now I know this is kind of just a workaround, but the goal here is just to make sure it makes sense of how we can get a -1 charge. Okay, so with all that being said, this I do believe is a chlorate ion because this is what makes sense. Okay, so now that we've gotten that out of the way, they want the electron geometry. So let's actually start going through. Chlorine has 7. Okay, oxygen has 6 times 3, that's 18, plus 1 more electron. So that's 8 plus 18. We need 26 electrons. Okay, so let's start with chlorine in the middle, because the only one that's different and by itself. Okay, we have 3 oxygens. Now let's fill out the lone pairs. We have oxygen needs, because it's sharing 1 electron right now, still needs, it's 6 more, 2, 3, 4, 5, 6. Okay, same thing, 2, 3, 4, 5, 6. Well, actually, I'm gonna put that down here. 2, 3, 4, 5, 6. Okay, and chlorine is sharing 3 of its 7. Okay, 3. So then we have 4, 5, 6, 7. So once again, we have something that says I don't really care about the octet rule. Okay, and the reason why I say that is because these 2 will bond with each other for then chlorine to actually form 2 double bonds with oxygen. Okay, and now this last oxygen, okay, it's like, alright then, what the heck, I guess I'll just be incomplete. But that's where the last electron comes in, and there we have it. In fact, let's count to make sure we have 26. We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So it does actually add up. Now let's see if our actual electron number for each one makes sense. So chlorine 7, that's what it usually likes to have. So now it's sharing it's not sharing 4, so it has 4 plus, but actually in bonds we have 8 in total. 8 over 2. So 7 plus 4 plus 4, that's equals to plus, well, minus 1. Interesting. I'm just double checking here. We have 4, and then we have 1, 2. Let's just do the math and continue and see what's up here. Oh, I think I see what I did wrong. Yeah. And see, this is why I really don't like the chlorates, because actually, you know what? Let's stick with this. This is a little bit tricky, I won't deny. Because yes, chlorine is breaking the octet rule, because I do assume it's in the middle. Or maybe is it drawn like that? If I did this. No, but then the oxygen would be really positive. If I did this, no, but then the chlorine wouldn't want that either. Yep, we're gonna go with this as our gut instinct, because chlorine is going to be the, I guess the middle one. But let's just see here. So we have 7 minus, we're gonna make sure that it's actually 26 electrons. 6 times 3, let's go 18, plus 7, plus 1, 26, yeah. And we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So we definitely have the right amount as well. Whoops. Of electrons. Okay. So with that being said, let's just do our math and just see where we get from there, okay? 7, 4 plus 8 over 4, we get minus 1, okay? Oxygen on the ends, like the 2 over here, it's 6 minus 4 plus 2, whoops, not 2. 4 over 2, okay, it's equal to 0. Oxygen at the end, we have 6 minus 6 plus 2 over 2. We have also minus 1, which doesn't make sense because now these two add up to a charge of minus 2. So let me just see actually what they have for the structure. Okay. Did I miscount? Oh my gosh, I miscounted. Haha. So I had the right picture, but for some reason I did not count clearly what it actually had. So that's why it's important to really make sure that you recognize what a bond is. This right here, that's what I was not counting as a bond because of the different coloring, but nonetheless I should have figured it out. So actually chlorine only has one lone pair, which is 2 lone electrons, plus it's actually sharing, okay, 10 electrons here, 10 over 2. Okay, so 2 plus 5. That's how we get it. Wow. Oh, that was really frustrating. So yes, exactly. This is where our minus 1 charge is going to be on that oxygen end. And now let's actually figure out the electron pair geometry. So for chlorine, okay, because these are double bonds, these are only going to count as 1 each. So we have 1, 2, 3, 4 for chlorine. So chlorine's electron pair number is 4, okay? And of those 4, okay, 3 of them are bonds, and 1 of them is a non-bond. So for the electron geometry of 4, chlorine is going to, this chlorate ion is going to be a tetrahedral. And when you have 3 and 1, you actually get, if I remember correctly, it's going to be a, not trigonal pyramidal, it's going to be I'm going to look it up here. Investment theory, it's going to be trigonal pyramidal. There we go. Yep. This is what it's gonna look like here. Trigonal pyramidal. So it's gonna look like CL3 is gonna look something like this. So it's gonna form a pyramid like that. One of the oxygens is gonna be a single bond. Okay, and it does have resonance because any of these oxygens could have been the single bond with the electron at the top like that. Hence how it forms kind of like a pseudo pyramid, because this is going to be like its base, the triangle, and everything's going to be pointing upwards. So with that being said, that is what chlorine is going to be. Apologies for that, because honestly that was quite the frustration of why I couldn't get that number to add up correctly even though I had the right structure. So with that being said, the electron geometry is tetrahedral. The molecular geometry, if they ask for it, is going to be trigonal pyramidal. So these are correct. So exactly, they say the electron geometry is going to be tetrahedral, okay? And they don't really go into the molecular geometry, but it depends on not only the number of electron groups, but also the number of lone pairs. Hence how I broke it down to the 3 and 1. Because 3 bonds, 1 lone pair. So exactly, that's actually what we have here. 3 bonds. Yes, I do see the double bonds, but the double bonds count as just a type of bond. Hence why we just counted as 1. So, with all that being said, chlorine or chlorate ion is a tetrahedral for electron geometry. And now let's move on to question number 19. That was frustrating. But I'm glad we're